I think the biggest misconception about whatever impending Mars mission that people think about is that it can be done easily.
But while the first space race was with the Soviet Union, this one is with China.
Liftoff as the countdown to Mars continues.
We need to practice the operational concepts and the science, before we go to Mars, because when we go to Mars, we should already know what we're doing.
Much of the terrain on Mars was made by the same geologic processes that shape the islands of Hawaii. We like Kilauea because it's nice and fresh. In fact, it's erupting right now and has been continuously since about 1983. Working on a volcano is not safe. If you want to stay safe, you stay at home.
We want to go as far as we can and then backtrack all the way. There are also places that we've gotten special permitting access to be able to go into places that relatively few people in the world have ever seen, and it's the ultimate exploration.
Terrain that we're exploring here is terrain that there's no way that we could send rovers into the rough kinds of terrain that we're able to go on with humans walking on two legs.
Astronauts report it feels good. T-minus 20.
Communications from the moon during Apollo were delayed by a little over a second. When we go to Mars, though, we're going to have a problem. Mars is so far away that when you send a hello from Earth to Mars, it can take 5, 10, maybe as much as 20 minutes.
How to get that information to the Earth, how to communicate from the Earth to Mars so that the scientists can react, so that we can make the best use of the expertise of the scientists back on Earth.
Okay, that explains why it was difficult to navigate. So when you're at the marker location, let me know, Kara, and I'll put it in the map note.
We care about the concept. We have GPS, we have wireless transmitters that we use to communicate things we have in the EVA backpack. So those are the main components right now that you need to function out in the field.
I think we can find some of these things in no time whatsoever.
I'll give you about 3 minutes.
Some of these ropey areas off to the south of where we were working. It's one density pair bag so far. Okay, that's fine. You can switch cameras.
I've analyzed moon rocks from every single Apollo program. You go out there and spend a few days on the moon, scoop up some rocks, and the next thing you know, you got 15 years worth of work ahead of you.
I could probably give you a laundry list of reasons why going to Mars and just in space in general is a good thing to do. We suspected for a while, and there was good information, that early Mars was a habitable environment, and Curiosity has really just confirmed that. And Mars is a good place to learn loads and loads about life in the universe. Sending humans there will give us a much better opportunity to answer those questions than just sending robots. We'll be able to answer them much more quickly.
It's like some steam? Is that, you're saying this feature is not steaming?
When the time comes to, let's say, plan out the actual surface missions, what we do when you get there, that they'll reach back to some of the work that we're doing now and make good use of it.
I think we're ready, Mike.
We're here not only to answer some questions, but we're here to find out what the questions are. If we stopped and said, okay, we've done it all, we know what we're doing, we're dead in the water.